The endless dark of the night sky is pierced by many awe-inspiring lights. Not all of this light is beyond our reach. Some is created in our own atmosphere. The Aurora Borealis paint the northern sky with spectacular displays of color. University of Iowa experimental space physicist Dr. Allison Jaynes works to uncover the physics behind the light show.
I study heliophysics, and specifically I look at energetic particles throughout Earth's magnetic field, both close to Earth and then also a little bit farther away between Earth and the Sun. Auroras are caused by particles that are somehow accelerated or lost into the atmosphere from space.
The aurora are caused when electrons from farther out in Earth's magnetic field come streaming into the atmosphere, sort of fall in along the magnetic field lines of the Earth and collide with the atmosphere, producing the light that we see.
Those are all manifestations of a bigger picture that we call space weather. Space weather is driven by the sun. Space weather has effects on human technology, such as GPS connections, our satellites, and how we communicate with each other.
And the particular type of northern lights that we study is very energetic, so it represents this large transfer of energy from further out in Earth's magnetic field into the atmosphere.
We put energetic particle detectors as well as magnetic field and electric field monitors onto rockets and go out into Arctic places, watch the aurora, wait for the right conditions, and we shoot a rocket directly into that space so that we can get measurements from inside the aurora. Students are the foundation of all of our sounding rocket missions. We have students heavily involved in everything from building hardware to going with us to the launch site to help prepare for the launch.
Unique opportunities exist for her student assistants to experience a NASA mission from proposal through launch and data analysis.
Students are very important for analyzing the data as well, so that can be part of what constitutes a good thesis project, is taking data from these rocket missions and maybe combining them with data from satellite missions.
Yeah, working with Dr. Jaynes is great. She's a pretty amazing advisor. She's sort of lets me go my own way on the research and try and figure out things, but is also always there if I have a question.
Students are a huge part of my research group. We have a lot of students right now working on various projects, everything from hardware and satellite instrumentation to data analysis of spacecraft data that's come back from various missions, and lots of collaboration with teams across the country. There's always new projects coming in from NSF and from NASA that require a lot of good student involvement.